At the National Robotics Engineering Consortium, we are using robotics to excite children about math and science. We are developing curriculum and training teachers in its use. We are creating a new tool to motivate children. In July, we hosted our first Robocamp, and it was attended by 110 middle school-aged campers. Children were given opportunities to design, build, and program robots. The kids loved it.
The students who are here today, all of you, have an opportunity. You will become the scientists. You're going to become the innovators. You're going to become the entrepreneurs of tomorrow.
Change is exponential in the digitally driven information age. The ability for future generations to continue these advancements is essential to the growth of our economy, the quality of life in our society, and our international leadership in science and technology.
First of all, about half of our kids go to college. And of those, only 1 or 2 out of 10 get a degree related to science or technology. And furthermore, what's really alarming is the numbers keep going down.
Less than 10% of students that decide to be scientists or engineers are female or minority. We need to do a much better job of reaching a larger segment of our population to excite and inspire them with science. When comparing high school exam results in a recent test of 21 industrialized nations, the United States ranks 17th in science and 19th in math. Traditional science classes involve experimentation, memorization, and a yearly science fair project. Students work in isolation or at best with a partner. Many children are not exposed to how exciting science can be. We found a tool that excites students about science and integrates real-world competencies. We teach robotics.
I thought I'd have a whole lot of trouble because it seemed all confusing. It turned out to be a whole lot easier than I expected after I got the hang of it.
This summer at Robocamp, children learn basic programming logic. They use conditional statements, loops, and wait-for commands. They use light sensors, rotational sensors, and touch sensors to make their robots autonomous. NREC scientists and engineers showed them how lasers, global positioning systems, and vision systems could be integrated to make real working robots.
We want to bring in teachers so we can develop curriculum with them.
Robotics is a great teaching tool. That's the reason we are launching our Teach the Teacher program in the fall of 2000. We found there is excellent educational robotics technology on the market, but there's not enough teachers who feel comfortable with this new technology. Our program will train over 1,000 teachers in the next 5 years that can confidently use robotics as an effective tool in their classrooms. They will affect the lives of over 1 million students. This camp could be replicated anywhere, but the added value of having it at the consortium was that campers were able to see scientists at work in the environment that they work in. Scientists and engineers gave daily presentations to campers. The first day, campers were introduced to RoboLab's icon-based programming software, and they were given several simple programming challenges. The second day, they were challenged to build and program several more robots. Counselors were there to ensure campers were successful and that they worked together.
We are doing a very good job so far.
From that point on, they worked in teams creating individualized autonomous robots. They worked as programmers, engineers, project managers, communication specialists, and information specialists. They were required to document their work on their team's personal homepage. They updated the page daily.
I asked Lisa, I said, what did you learn this week? And she said, I learned how to program. I said, really? Yes, I learned how to program.
Robots excite children. Whereas traditional science classes tend to leave the girls feeling intimidated, we found that programming and building robots inspires both boys and girls.
I think it's fun. I mean, people think it would be like really hard. I mean, robots, but it's not.
Robotics, because of the multiple disciplines involved, is an excellent tool for project-based learning. Throughout the design and documentation process, there are multiple roles that children are able to experience. The campers practice real-world, work-related competencies. such as time management, teaming, systems analysis, resource allocation, and information accessing.
It was hard at first.
It was really hard. We had no idea what we were doing. But then our counselor taught us how, and we just picked it all up.
And then by Wednesday we were doing it on our own. And we were getting it to work to that point, and we were getting into it, and we could do it better.
At the graduation ceremony, campers presented their results and design rationale using PowerPoint, as well as video and robot demonstrations. Our mission was to influence the lives of children and to make them aware of how exciting it is to be a scientist. Over a 2-week period, we demonstrated how children are motivated by the use of robots, and that robots can be used as a tool to excite students about math and science. Through our Teach the Teacher program, we hope to reach many more.
It was a whole lot of fun. I want to do it again.
Our goal is to team with NASA scientists, industry experts, and elementary, middle, and high school teachers to develop a world-class, standard-based curriculum accessible to teachers across the nation via the Internet. We will host regional and national robotics technical competitions, offer robotics camps for all age levels, visit classrooms and schools to inspire and demonstrate technology. We will continue to improve the curriculum based on testing and research. Robots have captured the imagination of people of all ages. We will capitalize on this interest. We will use robots and robotics education to excite a generation of students to study math, science, and technology.